Next, please welcome Shivika Bisen. She's a lead data scientist at PAXAFE. She has worked with various Fortune 10 companies in the computer and IoT space and graduated from the University of Michigan, Ann Arbor in December 2022 with a master in data science degree. Today, she's here to take a closer look at the testing of machine learning models in production, including unit testing, API integration testing, and simulation testing for machine learning models. Over to you, Shivika. Thank you so much.
Hi, everyone. So I am Shivika, and today in this talk, we'll be talking on what's the testing, how to test ML model in production setting, and what could be the testing strategy that we could follow for different machine learning strategies. So before we go deep into that topic, I'd like to give a brief intro about myself. As you know, I'm Shivika, and I'm lead data scientist at PAXAFE. My experience has been on the predictive modeling and online machine learning. I've done stuff related to NLP and search as well. So I've deployed all these predictive model on software and supply chain applications. When we talk about data, I have dealt with different types of data, whether it's like real-time, streaming IoT data, or time series data, text data. So I have done all of that. If you want to know about my education, then I did my MS in data science from University of Michigan, Ann Arbor. And ever since I graduated, I've been working on developing these data science models and shipping them into production. So just to give you context about where I work at PAXAFE. We are a 3-year-old startup, and we basically work in real-time visibility for business-to-business shipment. We are based off Indianapolis, and you can think of us as a operating system for cold chain and perishable industry. So we are a data intelligence company that build predictive engines and analytical engines for streaming IoT data, which is used in shipments. Some of our past partners that we work with are like Fortune 50 pharma company, Fortune 100 food and beverage company. Then we also work with Fortune 10 oil and gas company, and many more. So that said, I'd like to come back to our topic, which is testing machine learning model for production. So before I go ahead, I want to give you like a roadmap on what we'll be talking on. So first, we'll understand why this ML testing is even important, and then we'll see what is the flow of this ML testing. Then we'll see how to evaluate models, then learn something about pre-training testing, which is commonly also called as unit testing. Then we'll talk about the post-training testing, which we'll be looking into 2 different lenses. These are batch learning and online learning are 2 different machine learning deployment strategies, and we'll be seeing how to test these strategies after we train the model. And finally, when we do this post-training testing, we'll be seeing how our model is performing. And to do that, we have to simulate like an environment which is as close as to the real world. And that testing is called as stage testing or shadow testing. Once we do that test, we then finally do API testing, because most of the machine learning models are, they are accessible to users through an API, and that's why API testing is an integral part of this. So having said that, coming on to the main question, which is why ML testing for production is important. I mean, what's the point of this talk? Why are we talking about ML testing for production? So to answer that question, I'd like to distinguish between software engineering testing and machine learning system testing. So when you see software development system, right? If what you see on the left side, you usually have a data and then you have a logic, and that gives you a desired output. And in the software testing, you usually test whether that this desired output was good or not. But in ML machine learning system, we have different dynamics. So if you see, we give data to the machine learning system, then we give a desired output that we want the data to, the machine learning to learn from. And then the machine learning system learns from this data and desired output and then develops a logic. And this logic prepares a prediction, which is our main output. Now, as you all know, machine learning systems are used in most of the applications, which are also related to decision making and sometimes very important decision makings in businesses. So how do we ensure that all this learned logic that this machine learning system has learned is actually reliable? And that's why ML testing is really important, because we want to make sure that the learned logic is actually trustworthy to go with. But then you can say that, okay, we anyway do this testing when we are developing machine learning models, which is, we do model evaluation, where we test the accuracy and errors, and then that's, very basic part of any model development. But then I'd like to ask if this is enough, is a good model with like good accuracy or good evaluation, is that enough for the real world? Not very much, because you see, in machine learning, we have different metrics, which may not always be directly applicable for business applications. For example, business KPIs have different, they have different performance metrics, like what's the speed. Sometimes business may ask for, fast response. So what's the latency of the model? And then in other case, they might ask for a model that is able to handle a lot of data, so data load. So all of these metrics, which are useful for business point of view, is not really captured holistically in like model evaluation. So that brings on to our question, how is it being done presently? How is the more machine learning testing being done in current scene in most companies? So if just to give you a scene how it works, a data scientist really works on building the data. She builds the data, evaluates the data, or she or he, and then once the data is built, they will then give it to the other team. And the thing is that the model that the data scientist has worked on may not always have a best production practices, because it's after all data scientist school and not a software engineer school, right? So data scientists are good at building model, evaluating, training model, but when it comes to the production practices or software engineering practices, we do need other teams. And when this handling of the model happens to the other team, there might be some gaps in the model building which were not foreseen by the data scientist, and that leads to delay in the production, or some bugs might occur and the performance of the model may decrease after the production if we don't address those gaps which were important for the production. So that is why it is important for a data scientist, when he or she is building a machine learning model, to foresee what all step will come in production. And this will give them an understanding of what tests they can conduct beforehand. Before making the model into production, they should conduct some tests so that our model will be as much ready as it can get for a production setting. So that brings us to, what should be the flow of machine learning testing. So as we talked about, model evaluation, that is something that data scientist works on. They evaluate the model and then give it a go ahead for production. Now, when the model is, at the first stage of production, comes the pre-training test, which is what we call unit test. And this unit test is something that will check whether, stuff which are important before the model is trained in the production. Once unit test is done, then we have to check on the post-training tests. So these are the tests that we do once the model has already trained on the production environment. And these are tests like what's the speed of the response, like latency test, and then the load test, how much data can that model handle, requests that the model can handle. After we do this post-training test, we then come to a shadow test or stage test, which is just try to see how this model will perform in a very real world like situation or environment. And once we do that simulation testing, we then see how is our API performing, and if we can, see any issues with the API and machine learning integration. So that's the whole flow that at least we follow for our testing. Coming on to the first leg of the whole flow, which was the model evaluation, right? So first question in this stage is to decide on the metric. We have some common problems in business that we usually deal with, and then each of those problem type have their specific metric that works well for that type of problem. For example, classification. To give you a very simple example, say there's a classifier that classifies cat and dog picture, right? So that's a classification model, and for that metric would be accuracy, or true positive, true negative, false positive, and false negative. And then there is other problem, which is regression. So regression is when your output is more like in form of continuous number. Say, for example, if your model is trying to predict house prices, that's a regression problem. And for that, good metrics to evaluate are RMSE, ME, which is like a root mean square error, and mean absolute error, and adjusted R-square. Beside these two and beyond these two types of problem, there are other models like neural network and ensemble models that are kind of like a black box. I mean, they make a prediction for us, but we don't understand what's happening inside that model that is making that prediction. So to understand what's happening inside the model, why is it making a certain prediction, we make use of model explanation tools. And some of the examples are Lime and CHAP, that helps us understand which feature is playing what role in prediction of certain, whatever prediction we made. So these are handy tools that help in model evaluation. Once we do that model evaluation, we then come to pre-training test. This is the early stage when our model is like going towards productionizing, right? So you can call it unit testing. One difference of unit testing of ML system versus the software systems is that you have to take different aspects of unit testing. Like, for example, in ML unit testing, you will first see the input data. What's the format of the data? Then, is everything in correct type? And are there any NaN values? Is the shape of training and test set same? So all these are quick check that you have to do before you start training model. And then there is other aspect of unit testing, which is feature engineering. So this is an important one. Like, feature engineering is a very important part of any model building, right? So you have to test whatever feature you build are proper. Like, to give you an example, this is something that we experienced in our one of the projects. So to give a very simple example of that classifier of cat and dog, right? So suppose you trained your model with all the data of just cat and dogs, and then comes the test set has something very different, which is not a cat or not a dog, it's a rabbit, right? So how will the model will understand it? It can't classify because it hasn't really seen it, something which is out of sample data. It hasn't learned about it. So all of these things has to be taken into consideration when doing feature engineering. So once you do feature engineering, you have to test, can your model handle this out of sample data? And this is particularly important for the neural network model. Then there is another example that I can give, and that's something related to testing feature scaler, right? So I work with a lot of real-time IoT data, and that their time is an important feature. So for example, if you are giving time as an input to the model, they might understand it differently like how you understand. So for example, 24 in the our format, 24 is like midnight, and then 1 o'clock is early next day, 1 o'clock, 1 a.m. But the neural network might not understand it. For it, the difference between 1 and 24 is far, right? It thinks like, okay, midnight and 1 o'clock in the morning is far ahead, and then it learns, the learning happens inappropriately if that is what the model has learned from this example. So that's why we have to do something where we have to take care of feature scaling. Like, you have to take care of the nature of cyclic nature of the time, and to do that you can test these features and uh, make some alteration in your data processing technique, use sign and cause transformation to do so. So talking about that, now I think we now come to the model reproducibility, which is very similar to what we do in software engineering as well. So basically, you give same input to the model, and then you should try to see whether you get same output in all the systems that you're making test in. So that's like a model reproducibility test. And something very important to check with this is also the configuration. So your library should have similar versions, and all of this can be handled by Dockerizing the model, but still it's a good check to do before you go into further steps of testing. After this pre-testing comes the post-training testing, right? So before I go a little bit deep into what is post-training test, I'd like to talk about two different type of ML deployment strategies. One is online learning. So online learning is a deployment strategy which is used for streaming data or data which changes quite frequently in time. So here the model learns real time, and it tests and predicts real time. So basically there's no model saving happening. Everything is running on the fly. And that's why in this case, latency testing can be really important. Latency testing meaning you have to check whether, what speed of response your model has. So this is something that I experienced firsthand actually. So for example, on all this online model, if you are trying to train them with hyperparameters, you can't really use grid search CV or random search CV, because then that makes the whole hypertuning process quite lengthy in time, and that delays your response. So it is better to avoid such practices in hypertuning, and rather than going with that, you should experiment and decide on static values for each hyperparameters and then use it in a model, rather than doing it online, because it would be just too much of a latency to handle. Having talk about that, now we come to the batch learning deployment. This is something which is very commonly used in machine learning model, where like for the example that I gave about the classifier of dog and cat, right? The dog and cat faces will remain same over how many years you can think of. So that's why the learning can happen offline, meaning there's no change in the training data as often. So the model can learn offline, and then if it's presented with a new dog's image, it's able to classify based off the learning it did on offline, right? So this is something which is where the load testing is really important, meaning since lot of training data is required, we need to make sure that there is a parallel access to our database for all of this data. And one way to do that is to use SQL alchemy, that ensures that all of your access to DB and different DB connections have like parallel access. So this can be tested using synthetic data shipments. You can create synthetic data shipments and try to give it parallelly as an input to the model and see whether it's able to handle that. Another way to automate such kind of testing, load testing, is using some tools like Locust. So that's mostly what post-training looks like. After we now talked about the batch learning model, right? In batch learning model, I gave you a very simple example of cat and dog, but in real world, models are not that simple. Data change over time, and you have to retrain your model every time, because the old training which you did for your model may not be relevant after 2 months or 1 month, depending on the business case that you have. For example, if you are building a model that predicts the price of an item, if you trained your model like an year ago and now there's inflation, the prices would be totally different. So that gap, that change in the data which our model did not learn, was something we call data and concept drift. And one way to deal with this drift is to train our model back again. So this training of model requires some sort of A/B testing, meaning whatever we developed earlier, that's our model A, and now we developed a new model, which is our model B, and we want to see whether our new model is actually performing better than the previous model. We'll divert the traffic, 80% of the traffic to our old model, and then 20% of our traffic to the new model, and try to see based on a metric. That metric could be anything, whatever you decide for. It can be accuracy, it can be latency, load, whichever is applicable to your business application. You can choose that metric, and suppose the new model has a better performance in that metric, you then go ahead and deploy the new model. And that's how it works. So after talking about all this post-training testing, we then do something which is called stage test or shadow test. This is, you can think of it as something where you're trying to test your model in a very real world simulated environment. So before you put that to production, you're trying to see how your model will perform in real world environment. And that's why you are trying to simulate that with some situations, like giving it data which is very similar to the real world. If you have a real world data, then that's good. If you don't have, then you can break down and think of different edge cases where your model can fail. And then this requires a lot of brainstorming and listing out all the cases that can happen in the input data which can fail the model, right? So you give mock data to that, which covers all the edge cases. And then to simulate real world environment, you basically try to give the input parallelly. So for example, in real world, you might have multiple requests happening at one time. So you want to see how your model is performing in such case, right? So you prepare like a simulated input data where you have all the inputs given in the same time, and then you see how your model performs. So this is as close as it can get to the production environment. So once it is okay to see that, okay, the model is performing good in staging, then you forward it to the actual production. One more thing before you productionalize it is to test the API, right? So all these models are accessible to us through an API. Commonly, it's like one of the common ways to access ML model. And that's why some aspect of the API should be tested. So for example, error code, right? So these are cases where you have to think of, some issues you cannot predict beforehand. So that's why you have to keep some codes related to that. And this is to take into consideration that our API has to give some response no matter what, whether your machine learning model is giving you a response or not, your API has to give a response. And suppose your machine learning model is not giving a response, then you should be able to tell your customer or user why it's not giving the response. And to handle that cases, so we have something which is error code and status codes, right? So you have to build different error codes, listing out different extreme cases which can happen, in which case the machine learning model can fail. And basically these are issues that you cannot predict, so you can just give it some error code saying that, okay, this would be helpful to even debug something which if something happens in real world, you'll be able to see, okay, this is something that we need to think of in detail. And then there is status code. So status code, a very good example here I can give is, for example, we deal with a lot of shipment data, right? So we have coordinates, so latitude and longitude coordinates. If you test their data type, it would be same, like latitude will have the same data type as longitude. But what if when we were giving it an input, the user was giving in an input, they wrongly gave longitude instead of latitude, and vice versa? In that case, the logic of the model might break. So even though the data type was okay, it was still wrong. And to handle such cases, status codes need to be prepared, and we have to test with different data. We'll try to give the model similar data where we have this case of latitude and longitude reversed, and try to see if the model is able to handle that, and if it gives that particular status error related to this issue. So once we check that, we finally check the security, which is more like checking whether we have the right authorization in place for the model. And that's about it. I mean, that's the entirety of machine learning model. So just to end this talk, I would like to thank, it is my pleasure to be part of Convergence, and it's a great initiative by Comment to bring us all together. I would be happy to answer any questions related to my talk. You can reach out to me at shivika@BackSafe.com. Also, we are hiring, so if you are interested in joining our team, then please reach out to me. Thank you.